Thanks for inviting me. And sorry that I can't do this on a Tuesday, which is what I gather you all are used to. The first thing I should say is I'm not a composer at all, so this is malpractice. And second thing is that the technique for getting me to do a good lecture is to stop me constantly, because of course I have this nice organized thing, but it's going to be boring. But if you get me confused or get me derailed, then it will be much more interesting, most likely. So ask questions and object or whatever you want to do, and that will actually help. I think what I'm going to do is talk for an hour-ish, but then allow it to devolve into a question and answer thing. But if it devolves earlier, then so much the better. And the thing that I want to talk about is, all right, how to start this up. So it's easy to talk about stuff that you think you know about, and it's more interesting to talk about stuff that you are just kind of baffled by. And so what I'm going to try to do is talk about the stuff that I'm baffled by, which is the sort of huge undone aspect of computer music. So there are two ways of looking at computer music as a field. One is that it's kind of all done now, and the other is that there's a huge amount of stuff that isn't done yet, but we don't know what it is, and so we don't know how to do it. And so the hard part of any kind of research, but certainly computer music, is figuring out where the holes are. That actually, I shouldn't even call them holes. Where the vast space is that surrounds the little island that we sit on is actually the stuff that we know how to do. That so far is seeming pretty cool, but in fact, if you imagine the computer as a fully realized musical instrument, it's pretty clear that we're very far from being there. The computer is a lousy musical instrument, and so it's interesting to me the reasons that computers are lousy musical instruments. All right, so then the question is, well, why is that a question? Because of course a bagel is a lousy musical instrument in most people's hands, but you wouldn't want a bagel to be a good musical instrument, or rather you wouldn't think it would be one. But a computer, there's clearly something there that tells people that, oh, a computer, that would be a cool thing to make music with, right? In fact, the reason I'm doing this myself is because, oh, computer music, this is a good, what are computers good for? Well, you can make them animate bank teller machines, or you can make music with them. That's basically what your choice is. And the music thing wins out in terms of interest and cultural significance. In fact, it could be argued that the most important things about computers really are how they allow us to change the way we manage media in general, as opposed to how they allow us to analyze stuff or route money around, or all those other things that computers do. And of course, audio is a medium. And all right, so this is the first digression. Computers are, of course, visual things. The idea is you're supposed to use them to print out columns of numbers, right? Because that's what they're designed to do. And people seem to like to ingest numbers visually as opposed to auditorially. I don't know why that is. In fact, if any of you have an idea why that is, I'd love to know it. In pre-literate times, people would do things like build churches so that audio communication would work, so that you could go into you would have the purpose to having acoustic spaces that you go inside, besides keeping you dry, is so that you can actually understand each other, or at least so that you can understand the priest who's telling you how the social order should go down, right? And that whole history, at least in the Western scene of people being inside rooms telling you how the order goes down, and then making music to reinforce that message, is a completely auditory phenomenon that it's aimed at a pre-literate society, right? Because of course the era of building the great churches was the era before people largely knew how to read and write. So how do we get from there to a situation now where basically the visual, the reading and writing, is essentially privileged over what really is the primary mode of human communication, which is sound? Well, some thoughts about that. One is that pictures stay there and sound goes away real fast. So the pictures have a huge advantage over the sound in terms of perenniality and in terms of just plain old preservation. That, of course, has gone away now because we know how to record sounds. But on the other hand, if you got a recording of a sound and you got a thing printed on a page, the thing that's printed on the page is much more accessible than the recorded sound. So somehow the printed page wins, right? So we're in a of course we're in a weird spot in human history in a lot of respects, but one of them is that the rug has been pulled out from under music because we've turned ourselves into a visuals culture, right? And computers are a part of that phenomenon, right? Because in fact, computers are these things that do numbers, and that's all visual, and so we're now stuck in the situation where we have a thing that is primarily there for you to look at and do office work at, and meanwhile the real potentiality there is as a thing that you could construct or make be a part of a musical instrument, right? So, all right. So now a quick word on why people thought computers would be interesting in music from my perspective. So this is all stuff that is prehistory. The computer music is commonly thought to have been invented or started off in like 57 when Max Matthews wrote this program called Music, and there's this sort of shtick that one repeats about the official history of computer music. And the interesting thing to me is that the computer, or an interesting thing to me is that the computer seemed to be very interesting to composers. So even though it was Bell Laboratories, which was about the least composer-friendly place that you could imagine, I actually saw the inside of it, and it's just not a place where you'd want to hang out and compose. So you could do a lot of other things there. It's a place where you'd like to hang out and solder, right? Why would a bunch of... So it's actually quite a phenomenon that people like Jean-Claude Risset and Charles Dodge went to Murray Hill, New Jersey, and hung out with Max Matthews so that they could make sounds come out of speakers. And so to me, it's actually interesting to look at what Dodge and Risset did in that first explosive decade of computer music. It wasn't really explosive, but it was something anyway. That defining decade of computer music. What they did was they did things that used the computer's precision. So a thing about pitch is that you can hear about 3,000 separate pitches if you just go look in a book about the just noticeable difference in pitch. So pitch is a thing that's defined up to whatever that is, 12 bits of precision, something like that. That's the most precise thing that I know of that the auditory system can deal with, and everything else is way imprecise compared to that. Computers can manage numbers out to 6 or 7 decimal places just by default, and of course you can make the word bigger and have as much precision as you would like. And if you look at what Dodge and Risset and John Chowning, for instance, were trying to do back in the early days, you'll find notebooks that are scrawled with numbers. Like you could actually just sort of do numbers, and that could be part of your music. Well, now would that appeal to a jazz musician, a rock and roll musician, or someone who had studied Webern and all those 20th century let's get rid of intuition and formalize our musical thing people, right? Well, of course it's the let's get rid of all of our intuition and formalize music crowd. I guess maybe even Schoenberg can be accused of being the first one of those. The person who said, I don't want to be disturbed by these false notions of harmony. I want to, systematize my own listening brain completely out of my way of managing pitches so that no pitch will be hierarchicalized over any other pitch. So that whole movement, which of course, from some people's point of view, generated the whole 20th century classical music, and from some other people's points of view, it's the thing that destroyed classical music. Right? Well, and let's not get into that debate just now. But anyway, there was a huge number of composers running around in the 60s, back when composition meant you didn't touch jazz, you didn't even acknowledge it was music, right? So you would be someone like Charles Dodge, you would not want to go anywhere close to an electric guitar or saxophone, but classical music, piano, violin, soprano, that stuff. And of course, pre-composition, which means you write down a bunch of pitches, which are essentially numbers, well, they're tokens, and then you permute the tokens, so you make sets, and then you all that stuff, right, that you probably had to study in music theory, right? And so these people crowded into Bell Laboratories because they saw that they could not just bash sets with 12 elements around, but they could bash around sets with thousands of elements that were, for instance, numbers that could have many digits of precision. And you could just imagine that this would be hog heaven to someone who had too much Webern for breakfast. Right? Okay, is this making any sense? All right. This is my understanding of why computer music is what it is today. Right. It's that computer music sort of got laid out by these people in Bell Labs who had this particular kind of affinity for computers. So the jazz people and the rock and roll people did not show up, but the post-Webern people did. And so now we have this sort of notion that computer music is all about musical structures and permutations and algebraic computations and things like that can generate musical material. And I love this word material. That means a different thing to every person in the room, I'm sure. But okay. So just for example, Charles Dodge, I think I'm getting this out of order because this would be the 1970s, but Charles Dodge wrote a piece called Earth's Magnetic Field. And I haven't ever listened to this piece because people have told me not to listen to it. So I'm going to tell you not to listen to it. But what it consists of is a bunch of, as I understand it, consists of a bunch of sinusoids that are tuned to constants that he copied down from some table of numbers that amounted to what the Earth's magnetic field was that day, right? Or maybe over time, I don't even know. So that would be a thing that, that would be a computer music kind of a thing to do in the 60s or 70s. Jean-Claude Risset got very excited about spectra, and I'm debating whether to get into that. Well, okay, get into that in just a little bit. So a good thing that a computer can do, let's do it. All right. So I can stop talking for a second and try to get some trouble going.
I have a divergent question.
Oh, sure.
Would you say that there were any outliers in the early 70s? I mean, I'm thinking people like Laurie Spiegel.
Of course, right. And I should have mentioned her, in fact.
Who was, a top coder, but all the pictures you see are her there improvising with the keyboard.
Yeah.
Did she push the genre in a different direction, or do you think she remained an outlier until later on?
That's a complicated story because, in fact, Max Matthews himself morphed in the late 60s, early 70s into someone whose primary interest was real-time, quasi-improvised, or at least open-form kinds of
Sure.
ways of performing music on computers.
But I'm wondering about your take on
So I think I'm placing her a little later in time. In other words, I think that she's sort of a useful countercurrent. And in fact, I'm hoping that a little bit later on, things will morph a little bit more into the kinds of things that she was interested in than the kinds of things that Risset and Dodge were doing. But yeah, I don't know if she and Dodge and Risset even had any real contact. And I've never met her. In fact, I need to talk to her about this.
She used groove instead of music.
Yes.
So
That.
I don't think she was. But they were in the same building.
And Dodge and Risset would never have touched groove, I'm pretty sure.
Right.
Anyway, so yeah, so that's interesting, and also Bell. Well, all right, there's more to say about that, but I'll stick to the story, even though the story is, of course, manifestly only one tiny part of the real story, right?
Well, I was curious how the mainstream, what the attitude was toward anyone who wasn't really into big data back then, or wasn't using it the same way.
Yeah, and I don't really know.
But I didn't mean to.
No, actually, no. That's actually a useful question because in the milieu that I was in, which was kind of high art computer music, I didn't actually find out about Laurie Spiegel until I found her in an anthology or something like that. So she wasn't really sort of admitted into the canon. She is now. I mean, people know better now, but I think she was sort of thought of as an epiphenomenon at the time. And of course, the most important piece that she wrote was called Appalachian Grove, and that is not a title that would have perked Charles Dodge. I mean, it was manifestly okay. It was overtly bluegrass influenced, right? And so that would have been kind of the kiss of death for someone like Charles Dodge. Right? So she's really on the side of a big invisible divide. Yeah. Yeah, thanks for bringing that up, actually. That's interesting.
Yeah, she's in a bingo.
Yeah. Still active, by the way. Anyhow, yeah, so Oh, I was going to crack a patch out here if I can. And of course, this is high risk because I don't think I've ever run this patch on this computer. Let's see. I'm just going to show you something a little later that's what analysis is like. And stop me if this is just something that's too old for you to deal with, because this is not going to be anything new. Oops. Oh, no, don't edit the thing. See, I haven't told my computer that when I click on a PD, I should start PD, please. Okay, so I have to go over here. I'm very old school. I know this is weird. Okay, so now we're going to go into desktop. Gimme. All right, here we go. Harvey, more tools. And apologies for all of you who've already seen this too many times, which you might have. Now, how do I do this? I go over. What? Okay, go over here. Let's see if I got sound. Yeah. All right. Anyone who's listened to too much electronic music knows this sound. Pop quiz, what town's cathedral bell is this? Yep. All right, you guys have studied. Yeah, this is the Winchester Cathedral Big Bell. And let's see. So here's the thing you can do with it. You can say, I'm going to keep this going on in the background a little bit. By the way, this is ripped right off the CD, and Harvey thought that was hilarious. And then I'm going to just turn up my oscillator bank and do an analysis. And there's a bunch of sinusoids that there are mistakes in there, I can hear them, but those sinusoids are supposed to be one moment of time in this bell, right? Or, well, yeah, not to make too fine a point of it, let's go look at those numbers. Can I do this? Sorry, this is a terrible screen resolution for this. We'll do a save. And now we say that, we got a C that's about 43 cents sharp. And then we got an F up there that's 33 cents sharp, and there's middle C, 14 cents sharp, and so on like that. 6 digits of accuracy, big pile of numbers, composers in ecstasy, right? Here's the amplitudes. And then you get back on your synth and you do this and you get to hear what those numbers sound like. And then if you like some other collection of numbers, let's just do another snapshot. All right, and I can do this all day, right? And this is this is way oversimplifying, but that's something like the basis of this piece, Mortuos Plango Vivos Voco by Jonathan Harvey, that you all, I think, know, right? Which, this piece is many years later. I think this was 82, but this is maybe the clearest statement of what this computer music ethos is that I'm busy bad-mouthing. Right. I'm not really bad-mouthing it, but we'll see. What I claim is that this is interesting, and this is clearly a very kind of obvious way that you could use computers to manipulate sounds in the service of Western art music in the 20th century. And what I'm trying to do is claim that, in fact, that is this little teeny island of possibility that's surrounded by darkness that has to get explored, right? About which I can't talk because it's not lit up yet. So I have to talk about the place that we're at somehow, but then say where the stuff is that we can't do that we should be trying to go find out about, right? Okay, so let's find out what time it is. I've lost my watch. Oh, and my phone's off because I was. And it's really, I get 7:53, but that's West Coast, right? So it's 10:50. Okay, we're good. All right. Yeah, my computer does not know what time zone it's in automatically like yours do. Okay. All right. So that's sort of the prologue, if you like, of what I wanted to say, which is what people think computer music is. This is all stuff that came on before I personally hit the scene, and when I showed up, let's do this in order. No, let's not do it in order. So when I showed up on the scene, it was just becoming possible to do things in real time. And so there was another interesting period of history which might be called the 80s, or might be located. What I mean is that you might think that was what was going on in the 80s, which was that people were going to huge, sometimes comical efforts to make computers able to make music in real time. This was going on at Stanford and to some extent at Bell Labs, but the Bell Labs scene was a different thing, and that's the Laurie Spiegel thing I have to get to later if I can figure out how to address that. But there was another thing, which was the composers who had gotten all attracted to computers also got all attracted to the idea of doing stuff in real time. And okay, first off, who were these composers? The most interesting one probably was Pierre Boulez, and the sort of caricature that you could make of what Pierre Boulez was about was that he was a conductor. He ran an ensemble called Domaine Musical in the 50s and was a big proponent of post-war, as we used to call it, music. And his thing was he wanted to be able to have all the possibilities of electronics, including all that great accuracy and ability to deal with huge, complicated musical structures, but he wanted to be able to wave his stick and have the thing turn on a cue, right? And in the 50s, 60s, and 70s, what that meant was you had someone in the audience with a tape recorder, and you do this to get the tape real tight, and then you do that, and then the thing starts on a cue. And that's a miserable way to work. I've had to do that. And the thing goes bang, right? So someone coughs to cover the sound of this cat. Yep, that's all. Okay, so Pierre Boulez got the idea that a bunch of things happened. So Pierre, being fascinated by electronic music, having been in New York and probably having had a lot to say with Varese, who was working up in Columbia, but who was starting to become an embarrassment to the French because he was unable to find a place to operate in France. He had to be an expat in order to work on his music. So France invited him back, and to invite him back, his price basically was that they set him up with an ensemble and with IRCAM, which was conceived, in my understanding, as a place, as a research institute to try to get, and I'm conflating a bunch of stuff here, but to try to get computer music to be something that you could put on a stage. Bunches of other people were working on similar things, but they were working on it in ways that were not this sort of big science way that Boulez said about doing it. Boulez was used to big budgets. He was conducting the New York Phil, so it was not a problem for him to say, well, yeah, it's going to cost, we're going to have to hire half a dozen researchers for 10 years, and they're going to build this thing, and it's going to be a musical instrument, and then I'll do this, and it'll go whack, right? So he did this, and by the time I showed up at IRCAM in '84, the thing which was called the 4X was just sort of staggering up to its feet and starting to make good noises. And it was a thing that you had to go to IRCAM to access. So at that point, there really were two places in the world where you could go to get your hands on a real-time computer music synthesis tool. There was that, or there was Stanford, which had this thing called the Samson box. And there was the 4X, which was working, and there was Boulez, who still wanted to be able to cue the thing, and no one had figured out what the way was that you were going to get the thing to do to basically obey the cues, to follow the music. So I made a career out of that, which I won't go into in gory detail, although I'm using the products of the work that I did there even now. And so the purpose of what I was trying to do was simply to get it to the point that you didn't have to type in a number and then hit enter and then hear the pitch, but rather that you could come up with some way that you could make the thing respond to what's going on like an instrument might, and play the pitch when you do the thing to it that you have arranged to have to do in order to get that pitch to come out. And I'm sorry, that's a very abstract statement of what's going on, but a computer as a musical instrument doesn't have a playing surface. So when you invent a computer music instrument, you have to also invent your playing surface, whatever that is. And there are all sorts of ways of doing this, which of course I'd better not get into. But there's score following, which means synchronizing with a live player. You could try to conduct it, you could try to cue it, you could hook pedals up to it. You could actually build your own kinds of instrumental control surfaces. You could program it to wait around for network packets, on and on and on like that. And this is a huge field, and cool things are happening. And I think the watchword there really is the word instrument. The idea that rather than have the computer be a compositional tool, like a thing that you do office work at, the office work of composition, say, you would instead wish to have the thing be a thing that you're capable of playing as a musical instrument. And these days, well, it's a big field, and it basically kind of works. There are maddening limitations to what you can do with a computer as a musical instrument, but at this point, that idea conceptually is pretty well in place, I think. And in fact, Jaime is an excellent example of a person who makes computer musical instruments, right? And makes computers be musical instruments in some way. So that's going on, and I think the work is great. There are antecedents there that I ought to at least tip my hat to a little bit. This is a slight digression maybe, but it's this is a detail. It's not the case that electronic music wasn't real time before computers. In fact, computers were a huge step backward from the real-time electronic music practice that existed before computers became able to make sounds. In particular, what we call the studio era, which is maybe 1950s, when people like Stockhausen were cutting up tape with razor blades, one thinks of that as a non-real-time thing. And yet, if you've ever actually used a tape recorder, it's much more real-timey feeling than any kind of digital audio workstation that a computer could realize, right? So studios really were things where you could twiddle the knobs and get the sounds happening and move tape back and forth and just do stuff with your hands in a way that it would be possible to look back on with some sense of loss, because that sort of technology really is not very much around anymore. And that was it was a hugely real time and very tactile way of dealing with music. The only thing is you couldn't do it with the audience around, because time works differently. You could do things in real time, but then you had to put it down somewhere, and then you had to put it into a fixed piece, and after that everything was frozen. But there was real timiness going on. And then the other thing is and here's where the pop world starts to come in. Synthesizers like the Moog and Buchla, which came out in the mid '60s, by my imagination, my imaginary timeline attaches specific times to things, which is never that simple. But thinking of Moog and Buchla, although I believe it's the case that Moog and Buchla both were working primarily with serious music people. Not just dudes, because one of them was Pauline Oliveros, who was a very interesting voice from that era. But anyway, sorry, lost my stack. We'll get back there. Oh, right. So what ended up happening, despite the fact that Moog was working, I think, with John Eaton, I'm not sure. I might have the wrong name there. And Buchla was working with Pauline Oliveros and Morton Subotnick, basically trying to make things to put in studios. People like Keith Emerson got a hold of these things and started putting them out on stage and brandishing knives and doing all the hair rock stuff, right? Which turned out to be a much better use for synthesizers than the studio thing, at least in my opinion. So there's something there about the composers sort of shying away from that. Well, most composers sort of shying away from that and sticking with the computers, while most. Oh, this is a terrible oversimplification. The other thing is computers were much more expensive than synthesizers. So the composers I was hanging out with anyway were gravitating to the computers, but that's because I was at places like MIT and IRCOM. I think really in the rest of the world, especially for instance the rest of Europe, there were much different musical currents going on that were not part of this sort of high art mainstream that I ended up swimming in for that period of my life. So this is a horrible oversimplification to say that the synthesizer thing sort of went pop-wise, and the computers sort of stayed in the Webern camp, right? The rigor camp.
Until the PC.
Until which?
Until the PC.
Until the PC came along. Yeah, right. Yeah, that was the best time of my life, when people finally could get a hold of computers. Really, yeah, that was a good thing.
I was just thinking about the Atari. kind of disrupted the divide?
It did. And one of the most interesting characters there would be George Lewis, right? I don't think he had an Atari. I think he had what did he have? Was it? He had one. Okay, he had something like that. I can't remember what now. But he was hiding out in Amsterdam doing stuff that in some ways was kind of the perfect counterbalance to the high art stuff going on at IRCAM. And then he ended up in residence at IRCAM for a year or two, which was very interesting and strange, and showed up in that book by Georgina Boren. He got his 2-letter nickname, and he got studied. That was all very good. So, I recommend this book. Georgina Boren wrote a book called Rationalizing Culture, with which I don't agree in large part, but which is a fascinating argument about the sorts of things that I'm talking about, the sort of fissures between various kinds of artistic currents, and how technology was in fact used. I kind of part ways with her a little bit here, but she thinks of technology and knowledge, technical knowledge, as having sort of had cultural currency like money, so that you would get status in this milieu of IRCAM specifically by knowing stuff or knowing how to use computers or being able to access stuff, and then she tried to connect that with the sort of musical currents that were alive at that time at IRCAM as well. It's a very interesting read. So, at any rate, yeah. So I think what I was trying to talk about there was just sort of the real-time antecedents to the sort of high art real-time era that is actually where I got thrown in personally, but which in fact was going on all around me, kind of not totally unbeknownst to me, but in a different place from where I was. Okay, so now the other thing that was going on, or another thing that was going on, was composers were trying. Sorry, this is finally the subject of the talk. And we are now 8:07. All right, good. So, composers also, even since the studio era, which I think that's the correct thing to call this, the time that started in the 50s-ish, when people started making studios and making pieces of tape music in them. One of the flagships would have been the studio in Cologne, the WDR, which stands for something, and Stockhausen was working in there in the 50s, making pieces starting with something that I think might not exist called Study 1, but the thing that everyone studies now is Study 2, which, and I won't go search for it now, but you can imagine squares and trapezoids and triangles on a piece of graphical notation, everything based on was it the fifth root of 5, or was it only the square root of 5? I can't remember. There was a lot of 5 going on. So, the good old high art numerology thing again, but this time with the idea of realizing a piece of pure electronic music, that since it was not going to be played by any real person, but instead was simply going to exist as a figment on a piece of tape, didn't have any built-in requirement that it looked like a musical score. Right? So, and this is a way oversimplification again, but scores serve at least 2 purposes. They help composers think about their musical structures, and they help players know what notes to play. That's probably an oversimplification, but probably the bit about the score telling the player what to play came first historically, although I don't know that. And the thing about, now that we can write stuff down, we can do these manipulations, we can regard pieces of pitches as sets as opposed to just melodies, say. That might have come later. But now if you imagine someone like the young Karl-Heinz Stockhausen in the studio in Cologne, not having to deal with writing, the particular thing that he was writing was for tape, as they used to say. So it didn't have to fit on musical staves, and in fact, it would have been wrong to put it on musical staves because the time was not divided into quarter notes and eighth notes and so on, and the pitches were not divided into the usual pitch set that we use in the West. And so, but he wanted to write it down because he wanted to have a structure, and all those fives had to get worked out somehow. So it had to exist on paper so that it could exist as a proper compositional document that had structure of the appropriate sort to be sort of post-war music, and so he made up his own visual language for describing his stuff on the scale of fifth root of 5 or whatever it was, and 25th root of 5, right? The octave was a factor of 5, and he put 25 notes in there, if I remember right, and on like that. It's just kind of, well, you can just imagine. And yeah. And so now if you look at what a computer score looked like in those days, I don't think I have one handy, but imagine a stack of punched cards. And now imagine putting that into your punched card reader and having it printed out. And then you have a paper with a red line and a white line and a red line and a white line like that, and then you have numbers, right? That's what a computer musical score was in the language called music that Max Matthews put down in 1957. So computer musicians were dealing with things that were accordion paper, right? The kind of paper that folds like this, that you can hold up and scroll, and then you have like 100 lines per thing, and each one of them gets 132 columns, right? And on like that. That's those things, those collections of numbers are sometimes called scorecards still to this day, and that's the currency in which you explain music or describe music to, say, a musical program like C Sound or like Music, the original Music. Our program that's like Music that runs now is the program C Sound, in case you've used that. That's essentially what Max Matthews thought of in 1957, although there's history there that I shouldn't go into either. And I shouldn't take Barry Verco for granted either, because he was my prof and he's the one who did C Sound, so shout out to Barry. So now suddenly there's this tug of war going on in the computer music studios. Does this make any sense at all, what I'm talking about? All right. Yeah, and someone asked a question if it stops making sense, which it probably really has. I think you're just being polite. But, all right, so now there's this tug of war going on in people's brains between the conservatory training, which consists of perhaps starting someone at the age of 3, depending on what method with a capital M you're into, and drilling this thing into them so that they actually believe that music lives on those horizontal sets of 5 lines, which is a fabrication, right? It's not a fabrication. It's a means of storage. It's not the actual music in some way. All right. So, but anyway, you have this thing, and I can only see this because I didn't do this education myself. But people who have, like most of you probably, can actually look at a dot on a thing and just immediately either hear it or know exactly where to reach on the piano to get the thing, right? And scarier yet, you can actually look at those beams with the dots and the things like that and actually hear a rhythm, right? And this is a very mysterious thing to me because I don't do that, and so watching people do that to me is like watching someone ride a unicycle, right? As a slight aside, Stockhausen's, I don't know if he had any musical training at all, but certainly if he did, it was disrupted because he was 13 at the end of World War II, and he was in Germany at the time. So he went through some rough times where he probably was not doing the Suzuki method. Something else was going on, and this might have something to do with why Studia 2 doesn't use the notation. Although, of course, if you look at later Stockhausen, there's a lot of notated music there. It's not like he couldn't do it. But at any rate, he had a slightly less linear conservatory kind of background, which might have something to do with the fact that he was pushing on the notation as hard as he was. So the tug of war is this. You get someone like Charles Dodge or Jean-Claude Risset, and you would literally see their desktop with a score and a column of numbers. And you would And they would have spectacles on, and they would score, number, like that. That's how composers worked when I watched them when I was a kid. In fact, I think it's still, to a large extent, how composers work, with a couple of minor changes that are, I think, only cosmetic. The cosmetic changes are that the score and the numbers are frequently on the screen instead of on your desktop. But when they're on your computer, the scores are in Sibelius or Finale, or something like that, and the numbers are in number boxes, or whatever you're putting yourself through by way of music realization, and you are still copying the stuff over from the one thing to the other, right? And that's what this talk is about. It seems to me that is something that we need to think about, learning how to do better and more fluidly. And what I want to do is then show you what I've tried to do to see if I could make something like that. And this is not, well, I actually can tell you that this is a failure, because it's been in existence for at least a decade, and it has not taken off. People don't even know this exists, even though it's in PD, which everyone has, right? But I'll just show it to you now. And I'm going to do it the hard way, from nothing, because I want to show you how lousy this is. And then you can see how you can think about why you might want to do this better. And I actually haven't done this from scratch in a long time, so I'm going to make some mistakes. And what time is it now? You know what? I'm going to try to do this in 10 minutes, and if I can't get anywhere in 10 minutes, then I'll just go grab one that's already done, right? So here's the deal. Why don't we... all right, so this is an empty window, but what I'm going to do is, rather than putting stuff that PD knows how to do, so there's a part of PD that's just max, where you say, oh, give me an oscillator, please, and then you do that, right? And then there's the part of PD where you have to make it up yourself. So what I'm going to do is I'm going to get a window, and I'm going to call it X. And what X is going to do is it's going to hold a graphical score, right? And so what I'm going to have to do is make up a score language. This is going to take 10 minutes, right? I'm going to make up a score language and start putting score objects on there, and then at least indicate to you how you would take that and turn it into sound, right? So what I want to have is I'm going to start just really simple by making a rectangle, and I'm going to have the rectangle have a position and a size, and those are going to be numbers that I can get in and out of the real-time aspect, and that's going to be sort of a Studio Zwei tip of the hat, not any more than that, really. Okay, so what I have to do is I have to make a window, which I'm going to call struct1. I don't know why. So you can make things that have, I think of these as data structures. And so this window, okay, so we're going to have three windows now. The untitled window, which I'm going to save just in case we crash, because you never know, right? Oh, I shouldn't have called it X, though, because that's X. That's going to be confusing. Let's call this Z. All right? Now we'll be less confused. So then, okay, so we have three windows. This one we can ignore at this point. This one is going to be the definition of what a score is, and this one is going to be the score, right? So first off, I have to do some defining. So I'm going to say, those of you who know C will recognize some ideas here. So I'm going to make a structure, and the structure is going to be called rectangle, and it's going to have numbers in it, because computers do numbers. So we're going to have a floating point number X, a floating point number Y, and then a couple more. How about, let's call them width and height. So, okay, and then I'm going to have the thing have a way to show you what it is, right? So right now it's just four numbers. So what I want to do now is draw a polygon. Is this really going to work? First off, is it really called draw a polygon? Yes, it is. Okay, and I'm going to do what I tell everyone always to do, which is get help and just find out how this thing works. So what I'm going to do is I'm going to blow off all the options, and then I'm going to say there's going to be a RGB color, and then there's going to be a line width, and then there are going to be coordinates. Now, what does weasel mean? Can The numbers, oh, right, of course, right, that's important. Okay, good. So what I'm going to do is I'm going to say, we're going to draw a polygon. Sorry, this is an example, but I don't want to do the, I don't want to get the example that's made. And the polygon is going to be black, and it's going to have 2 pixel wide borders. And its coordinates are going to be the origin, and then 0, 10, and then 10, 10, whoa, no. And then 10, 0, and then just go back to the origin. So I just drew a shape. This is stupid, right? And now we're going to make one. Oh, this is going to be awful. So now what we're going to have to do is we're going to have to, I apologize for this. We have to get a pointer which is going to allow me to refer to the window Z. And I'm going to have to refer to the window Z, and then I'm going to have to append to whatever is there, which using an append object. I'm going to want to append a rectangle. So I think all I have to do there is say append rectangle, and then I'm going to give it values for X and Y, maybe. Why not? Okay. And now I'm going to bash the pointer into the append. I'm sorry, I'm not going to really explain all this as carefully as it should be done. And here I'm going to say, let's go look at the, need an A in there. Let's go look at this window Z, whose actual name for PD's sake is PD-Z, to make things either less or more confusing, depending on how you think of it. And then, oh, is that a Q? Yeah. Where's the A? A? Yeah, this is Philippe Mannery's computer, so the Q's in the wrong place. Traverse PDA, and then I'm just going to say, how about just output what you got when you did that. And this will not work, right? And then I'm going to say, all right, this is good, and now append is going to append a rectangle, and X is going to be 50 and Y is going to be 50. Now, do you believe this is all going to work the first time? Whoa, look at that. Rectangle. All right. That was actually a minor miracle. If I'd gotten, well, you get the idea. Okay, so now let's, just to see if this is really working, let's just change one of these numbers and see that we, okay, we're talking, we're actually doing something. Now let's actually make it show some data, such as, let's see, oh, first off, let's go over here. Now that we've got this nice rectangle, we can do things like edit it, right? So now we can make ourselves a nice little score. Okay, now let's make it be different depending on data in some interesting way. So what I want to do is I want to say, rather than go to the point 1040, I'm going to go to the point 10 WQW, and then let's throw an H in there somewhere too. Okay, now what I've done is I've fixed it so that 2 of the coordinates of the rectangle depend on the numbers W and H, which are part of this datum piece of data. In fact, if I go over here and get properties on this thing, I'm going to find out that I've got a nice rectangle. X is 112, Y is 89, and W and H, which I haven't set, are both 0. But now I'm going to make them be numbers. And then I'm going to say, okay, and look at that. I got myself a thing which encodes some, well, it's got a position, which is X and Y, and it's got values in it, which are, whatever that is probably, is maybe H, and whatever this is, yeah, is W. And none of the rest of the stuff will allow me to edit it because I didn't make them variables. They are constants. So in here, I can make the coordinates of my thing be constants, or I can make it be variable. And now we are just in hog heaven, right? But we've got a situation now where we can make data here, and we can even, I can prove there's data because I can go here and get properties and see the data, right? And of course, this is 4 numbers, but imagine that there are hundreds of numbers there. Maybe there are arrays in there, or maybe there's stuff that's not symbolic instead of numeric, and blah, 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 like that. So this could be a tremendous amount of stuff if you wanted to. And now, why isn't everyone using this all the time? Well, part of it is that this is a real pain that you have to make the Starship Enterprise just to put the first one up there to get your little shape to show up on the screen. That's a problem. But that I think you could work around. I think that could be done better if there weren't more fundamental problems. While we're there, let's get out of here and just make a little traverser thing. So what I'm going to do is get back into the main window, and I'm going to make something that goes and grabs the data so that I can do something with it. So I'm going to say pointer. So a pointer is an object in PD that just points to one of these things. And then the basic operations are, I can tell it to go to the beginning and go and look at the next one. Right? Really fundamental, basic list chasing stuff. Oh, my 10 minutes are up in 1 more minute, I think. Okay, so what I'm going to tell the pointer to do, and this is ugly, is I'm going to tell it, okay, we're going to traverse. It's probably a bad choice of word, and it's going to be PD-X. That's the same thing I did to get pointing into the window so I could put one in there. But now what I'm going to do is I'm going to get in there and say, yes, please, and then I'm going to give myself another message to the pointer to say, give me the next one, please. So that's going to be like this. Next. And then what comes out of here is going to be the thing that I'm pointing to. So then what I'm going to do is I'm just going to get everything out of it and look at it. So what that is going to be is I'm going to get out of my rectangle. It has to know what structure it's getting the thing out of, and I want to know everything: X, Y, W, and H, like that. And those are their numeric values. So let's put some number boxes down there. Pain. All right, now we'll start. Now we'll say next. Nothing happens. All right, look for error message. List PDX not. Oh right, I named it Z because this is X. Yeah, and there's my score. Right. So the first one actually is the one that I was messing with, but I could change some of the other ones too, and then I would have no. And then I would have various, just do something at random here. Hey, let me get you. All right, well, whatever. Was this one the other thing? No, was this the other? Where else is the hot? See, you can't see where the hot points are. That's funny, the cursor should be changing and it's not, so I can't explain that. There, okay, good.
It's filling yours.
Is it changing? I don't know. Anyway, I don't use this a whole lot. And if I don't use it, who else is gonna? And now I can just say, okay, there's my musical score. Now what you could do if you wanted to hear this, I'm not going to do it. You could make one of these things like X be time, and then you would make that talk to a delay object so that it would look at what time it was and delay that amount. And then I would take the other 3 things and send them off to parameters of some synthesizer voice, and then you would hear blim blam bong, and then you would have computer music. All right. Okay, now. So why isn't this just sort of the solution to all your problems? I think there might be many.
I'm a little bit, just to play devil's advocate. So why is this better than my simply writing shapes for my score that I think represents the music?
So the thing that might be better about this is that the computer can get it. In other words, I can change it and then hit play and hear it.
Okay, so in other words, if you want to change things a lot, this would be a lot easier. You wouldn't have to.
Then if you knew what you were doing ahead of time. Yes, that would be a thing.
Once you got to a finished point, well, I guess, why would you need the graphics before you got to the finished product?
That's an awfully good question. That points out to the idea that there was maybe some assumption about what the working process was here that wouldn't align with necessarily the working process of most composers.
Well, I'm just throwing out things.
But then, if you think about, say, the studio era when you could get your hands on the tape, presumably people proceeded from experimentation. Mm-hmm. So this is very much more experimentation oriented, I guess, than it is writing oriented, right?
It's intervening too in the truly one-to-one oral, brain oral loop.
Yeah.
This is introducing a conceptual intervention that you could use to generate transformations that are not one-to-one parameters that you could even hear or imagine. But I didn't. Can you back on your question? I didn't follow what the traverse was traversing.
Yeah, the nomenclature here is weird, and I need to find something better. So the deal here is
that it's interpolating between. Is it?
No, it's actually just it's pointing. It's sort of referring to one and the next object in sequence. So an example from Max would be you could have a call object,
Right.
and you would just give it a number to say which line to go to.
Right.
But here they're not numbered, so instead of that, you have to have a way of just stepping through the things.
So when you click next,
It means
where did
okay.
it jump to?
So it went to the next one of them, which is the next one of these three. So this message traverse tells this pointer to put itself at the beginning of that window.
It's jumping from shape to shape.
Yes. Ooh, I didn't explain that. Ooh, that would have been a serious lacunae in the explanation, right? Yeah.
It's pretty interesting.
And it goes like left to right.
You can ask it to, but I didn't. So it actually goes in the order that I put them down in. I was rather extremist about not putting any musical knowledge into this, so the notion that left to right should be time is not built in. In fact, this might be pre-compositional in some way, as opposed to a score. And another thing, this might be an advantage and might not. You could imagine having this, in fact, be recorded from some kind of real-time input. Like you might be playing some control surface and PD might be gathering that data and turning it into these shapes to transcribe something that you're doing. And then you would be able to take the shapes and edit them and then turn them back into sound.
Well, the other thing is that it would be very accurate, and so it would probably be a lot more accurate than anything by hand.
Yes and no. In fact, the maddening thing about it is that I just want this thing to be middle C. So where's middle C here? So, I mean, the only way I know that you would be able to do that would be to just play it over and over again and tune it, which is precisely how I would like to do it. But on the other hand, that seems like the long way around because you could just say 60, right? But you can't. Yeah.
Couldn't you right click on it and open it and edit the...
You can. Yeah, of course. And another thing you can do is you can just say, I'll probably fail again, but let's get the structure back. I can actually ask it to show numbers if I want to. So I can say, draw number, and I forget how this works, but I guess you have to give it coordinates to put the number at, and then you have to give it a color the number is going to be at. So let's look at the number W. Didn't work. Do I need to, I need to say W first, maybe. There it is. So W is 50 over here. Now I really could make my 50 be 60. And then I could go over here and I could say, all right, that's cool, but oops, wait, I don't want one of those. I want one of the, go away. I want to toggle. And now I could make it actually show me that or, hey, come back here. Hey, where'd it go? All right, okay. Show it or hide it, depending on whether I want to see it or not, right? So that seems like that might be a help. But in fact, I've gone, I won't drag you through it, but I've actually gone, working with Philippe Mannery, went and made a whole thing for notating synthesis parameters for a complicated synthesis thing in this kind of visual language. And it never got to where it was something that you would ever want to use. It got complicated faster than it got useful. Yeah.
Okay, so I'm wondering about this because it was very cool from a perspective of you input data and it's almost like kind of a priori form of sound experimentation. Like these shapes will represent purely, like they will have pure sonic representations afterwards that come from the shapes. So the sound is representational of the graphics board,
Yeah.
whereas the dots and lines are representations of a preconceived sound, right? So I'm wondering how we stand in terms of, like, even if you were to work with synthesizers and create compositions or sonic works, whatever, is this still representational in a way that makes sense to us? I mean, it's not really a document that records, it's more of a document that presages. Or I'm wondering in terms of, like, does it really solve questions of, it's sort of two different worlds of
Yeah.
how to represent, you know what I mean?
Uh-huh. And that's a whole thing that I don't know how to navigate, because you could be scorish about this, but then you'd want to have those staves, because that's how people see music, and it's also how people know where to reach on the piano. But you would also want to be able to have, if it's a computer, you also want to be able to manipulate data. And I guess the main thing that I want to say is that I still don't know how to make something that makes both of those modalities available. Because, I mean, it would be easy to throw staves on this thing and put dots on them, but that's not what a score is. A score really is about the relationships between the dots. And that's a completely different thing from what this is, because this isn't about the relationships between the shapes, it's just about what's internal to the shapes. Or something like that's going on.
Yeah, it's prescriptive as opposed to descriptive.
Yeah. I hadn't thought about it that way. Yeah.
But it's not recognizing the space between them. There's no way to have it.
Well, you could. I mean, you could make a patch that went and did that, and that's when it starts to get complicated and heavy, when you start trying to do that kind of thing. Like you can make groupings so that you move one thing around, and another thing knows about it and reaches over where the thing is. And you can make beams happen and stuff like that. And pretty soon you'll be really miserable, because it's very complicated to do. And it's not really set up for doing it well.
You
Yeah.
can do it through scaling, right? I mean, to set up relationships by scaling the data to the
Well, I guess I'm trying to figure out if did you have a priori conceptions of whether it would be used as an interface, what you called, what term you used, when you design an instrument? Is it an instrument interface, or is it a compositional?
Right. Okay. So in my mind, PD and Max are good instrument building environments, but they don't have any way of describing musical structures. This is an attempt that is different from that, although it's integrated into PD, which is trying to be a way of describing musical structure, which in fact isn't describing musical structure, but maybe is describing piles of data in a way that would be useful to someone that wanted to make sound. And is precisely not doing the thing that Alec is saying that it's not doing. Yeah.
It's deceptively simple. Meaning it seems simple, but it's actually something that nobody's done.
Yeah. And I haven't done it. Yeah, or rather, the thing that I've done doesn't turn out to be what people seem to need. What do people need? Well, that's you make needs up by inventing possibility, right? So that's not exactly what I should say. It's but it's not taking off in some way in the way that.
But it seems like the problem is an ongoing one of how to represent all of this in a score.
Yeah.
There's no really successful way, it seems.
That's right. That's right. And I think that's worth thinking about.
Pre-sound. We're talking about pre-sound.
Well, to just represent, to represent whatever's coming out of the computer, so
In a symbolic way.
know what they're, can be helped.
You know, when a composer is writing an electronic score out in staves and they make a squiggle, this could have been that.
There's an example of that. I've seen scores where a composer takes a printout of a sonograph and tapes it on top of the score.
Right.
And, coaches the players to read that. And it's quite fun. So I'm playing devil's advocate in other ways. There's more of a one-to-one correlation.
Yeah, but you would never realize the electronic score that way, right? Because you can't turn a sonogram into sound.
Right, right. So this is pre-sonic.
Yeah, that's right. Although, there are examples of, I mean, you should be able to go back and forth, and although it's not useful, I will show you an attempt at that.
Because you were talking about a score that represents the final product, right?
No.
So this is data in the same way, although it's a more complicated thing, but it's an editable thing, although at the outset it was actually a sinusoidal trace of a real input sound. So another part of this holy grail thing is you ought to be able to grab a sound, throw it on the page, mess with it, and then have it still be sound at the end. Right? But this doesn't turn out to be terribly useful. Yeah?
So what you're saying is that it could represent visually the output sound if you set it up to do that.
Well, to the extent that this is a visual representation of the output sound, which maybe it partly sort of is, yeah. But then but the more precise you get about how you represent the sound, the harder it gets to get in there and edit it, practically speaking. At this point, here's a bunch of partials. How would I change the pitch of this person's voice? Well, I'd have to take each of the partials and nudge it and do that all in parallel. And if I didn't get it exactly right, then it would be in harmonic.
So who have you kind of prompted to experiment with? Whatever you call this?
Yeah, I don't even know what I call it. This actually was the point of departure of pure data. In fact, so I threw the Max-like stuff in so that I could make sound with it, but this is actually the fundamental design. These are more basic objects than the objects in PD. And I show this around to people, and they say, "Oh, that's cool," and that's kind of where it stops for the most part. A couple of people have made scores sort of in what-if mode. Oh, I'll see if I can do a little tape montage piece with this, and done it, and then sort of, okay, that was okay, but the columns of numbers would have been just as fast. It hasn't yet found its sort of, oh, this is what this is cool for kind of niche yet.
To me, it brings up like at what level of the sound you're representing in the score. So like this, in the score for an acoustic instrument, I might not say tell the performer what colors you use. I say what this pitch really was. Like you could do your coloring as the performer, rather than be writing that down in the score. And the shape kind of makes a more structural moving of the data that I think is really useful to think about in terms of the score of the computer as an instrument.
It will also kind of bizarre kind of manipulation of these sets of parameters, because it's a tactile, tautological transformation.
Yeah.
It's a tautological transformation that is totally unlike anything else computer musicians have done with streams of data.
Yeah.
It's not a function.
Right. No, it's just data, right?
But I mean, there's only so many things you can do with a given shape, right? And the shapes they're all 2D.
Yeah. I mean, they're what you make them. So, but yeah, the screen's 2D. It can't be more than that. But
you could have modeling of 3D objects if you took this to another
oh yeah,
level,
so you could
right?
have this be a projection of and to a limited extent, it's possible to do things like that with it. But what that implies is really that you'd have some controls that would change your viewpoint on it. And so, thinking more generally, a point of departure might be turning aspects of it on and off, but also changing the scale that you see things from. That kind of stuff. And those things are there are crude ways of doing that built into this, but they don't get far enough to people. Well, I don't know. It gets complicated faster than it gets useful, right? So you can go in and do things like that, but it will take you hours and hours of painstaking work to get to where you can do it.
But this seems really useful for example, what you were describing, doing the mapping for Peter Evans' piece.
Oh.
Where you have pitch and location.
Although that didn't use any of this at all. That was just give me the pitch mod 6, and that's your speaker number. So it's pure algorithm at that point.
You know, I was curious, it's only sort of partially related to this, but a number of us were at a concert last night, and I was wondering, in working out these pieces, what your process was with Rand. In other words, was there a lot of experimentation involved in trying to get things right, or did he simply write a piece and tell you what to do?
Yeah. To tell you the truth, I don't really remember. The way I work with composers is very long term. Like I started working with him in 96, 97. So there's this very long cumulative process building going on to the point that basically he or Mannery, for that matter, do what they're doing, and then they call me in when they don't know how to do something. But in the days of getting set up, it might have been radically different. But basically, at this point, I mean, those patches are built by Rand, although he's got a huge library of stuff, much of which I invented. Like, you know, the bassoon fuzz thing, that was me yesterday typing into an Expert box, thinking of a good fuzz function, right?
But was that, that's what my question was that ad hoc that you just decided to do, or you said, well, if you feel like we'll do this, or if he told you we'll do this at this point?
That particular one was, he had a distortion thing that he had worked up, and it didn't sound good, and he said, I want it more like blah, and so I play guitar, so I knew how to distort stuff, and so I said, okay, well, arctangent then, and right, yeah.
But along the same line of the loose question, there's a certain unpredictability sometimes about you write a piece for solo instrument and live electronics. So how I wonder how different composers that you work with, how that process really works. Did they write a little bit of clarinet music and then they test it at home? It seems like so unpredictable unless you have a very, very clear idea and knowledge of what the possible results are. So I wonder how collaborative it is in that sense.
That's part of what took whatever that was, 15 years. The Rand actually getting to the point that he knew how to deal with the unpredictability of it and design a situation that would work given unpredictable playing, say. Right. So that was sort of that was a years-long process of kind of learning what kinds of things work with what kinds of input, and when is it the case that you can predict what level will come out? Sometimes you can, and sometimes you can't, and on like that. I mean, at this point, he's got himself a palette of things that he uses over and over again. In fact, it was clear during the concert that things would come back, right? So he sort of got his ways of doing things, as many composers do, right? If it's a John Channing piece, it's got FM in it, you know, and so on. And so he's worked his way into having a situation where he knows exactly what to do with things and knows how to predict what will happen and knows how to test it so that he can know before the instruments show up. He actually uses Digital Performer he's got a monster sample library going, and so he actually made a sampler rendition of all that music and ran it through his patches over and over and over again and got the balances right and so on like that. And then the instruments show up in the mics and they're all wrong, and then you fix them, you know. But he knew what he would have to fix. He knew what would change and what he had to use rehearsal time for. But that's decades of experience that go into having a practice that allows that.
And what about someone like Boulez that totally came from a different?
Yeah.
I wonder how someone like him would work in terms of just very clear musical ideas and what the electronics should do, or
yeah, I don't think he's touched a computer in his life.
Yeah.
Still, right?
At your comment when Ray Palm, for example, was being...
Yeah, Ray Palm was between versions. Ray Palm's always between versions. Ray Palm was between versions when I got there. Yeah, and the deal was Boulez would show up at like 7 a.m. and Andrew Gurjo would be there, and Andrew would play him what he'd been able to do, and Boulez would tell him, well, okay, I want this, and then he would come back in 2 weeks, and that would go on for years. That's actually a very slow way to work. It was a good thing in that it didn't use a whole lot of Pierre's time, but on the other hand, it didn't put Pierre in control of what really happened in any very serious way. And it's interesting to hear the progression from Répond onto the most recent thing he did, the violin piece, which is very, very busy. Well, Répond is busy in a different way, busy instrumentally, but the violin piece is, he's throwing samples on violin attacks, like the violin's going noodle, 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 and it's just thing, 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 just one after another, like much too much, in fact. And that must reflect an accumulation of palette again on Deleuze's part. But I also think that his musical assistants were getting a little bit too trigger happy.
Do you have any examples of resynthesis? Like, so it's very clear that you can make notation, but
Well, yeah, but they're not very exciting. Like this thing I can resynthesize. So I've already edited it somewhat, but this is this thing. Is this gonna work? Resynth. Sorry, you've heard this, right?
I don't think so.
Oh no?
Continuous soft and relaxing.
Right. So this. Well, you've heard the sample, I know, but this is some radio announcer.
Continuous soft and relaxing.
So that is this,
Continuous soft
which is
and relaxing.
which is a rendition of these sinusoidal traces, right?
Even with does it still have the edits you did?
Yeah, but the thing is, I didn't edit anything terribly important. That you never know what's important and what's not,
Right.
right? But now I'm going to make it, okay, so this is the word relaxing, so let's give him a nice gliss, like that, right? And now we'll hear something, I think. Now I'll do it, yeah. I don't know which of these harmonics is loud, and of course I'm bashing him in inharmonicity too while I'm doing this, right? So this is going to be
How is the amplitude of each of these phases represented?
it's not shown, which is I should have made the thickness represent the amplitude. Although, if you do that, then the whole thing turns black. So I don't know how to do that in a way that, whoops, that's why I already did that. All right, let's see what we got now. So now the last word, relaxing, is going to be messed up.
Continuous soft and relaxing.
Okay, that's interesting. It's not music. So that proves you can go in and change stuff. It would be really cool to be able to grab sound and really edit it and say, I want you to do this, and really be able to do that in a deterministic, composer in control kind of way. But this is,
And
just
is
a toy.
the visual resolution aliased, or is that so? In that, yeah.
Here. I think it's 4 pixels the halftone or something like that. It's whatever I was able to get on the screen. And it's not enough. And then when you make it enough, it gets huge, and then you can't,
So the screen is limiting the resolution of the data? No.
Yeah. Actually, the mouse is. In other words, the mouse is rounded down to the pixel. If the mouse were more accurate than a pixel, then I could be more accurate myself.
Right.
And in fact, I was going to show you something else, which is there are techniques now where you can just make a scrawl on a piece of paper with a pencil and then analyze that as a trace and get the numbers out to arbitrary accuracy. So actually, I'm sort of leaning in Xenakis' direction with this a little bit now. But that's a thought experiment.
I should. Do you know about Federico von Reichenbach in Argentina? Before Xenakis,
No.
he did it's called the graphic analog converter. I should show you this.
Yeah.
He did, and Xenakis then went to the Vitella Institute and saw that. So it's a pre-Xenakis graphical, sinusoidal.
Interesting.
scored
Yeah,
meter.
Yeah. Now in Xenakis land, a centimeter was a halftone, and I think he had millimeter-ish resolution, so he was getting down to 10 cent resolution. And you can do that if you have a big, fat, picture going. Yeah.
So in theory, if you increase your resolution, then you'll get better resolution.
I guess.
HD will really affect.
I mean, HD, what is it, twice as good resolution as, not even twice, right?
19.
They always say the number of pixels went up, but the number of pixels in both dimensions, so doubling the number of pixels only gives you half again the resolution. So I don't know. I don't think it's not that exciting, right? Yeah.
I mean, translucency is really good, or opacity. That's
Mhm.
really good. But I'm not sure if that requires a different graphical process.
It might, yeah.
Very complicated.
It might well, yeah. Although, I don't know. I haven't even looked at that and seen if that's possible. Yeah.
What kind of parameter mappings have you used in experimenting with your shapes?
Kind of the obvious ones, like making things where the shapes would indicate center frequencies of filters, or traces would indicate parameters going up and down in time, and what else?
For consecutive sounds or simultaneous sounds or components
Oh.
of the same sound?
Yeah, that's actually a huge problem. Is when are things part of the same object and when are they not?
Yeah, that's what I was thinking about with Honey's talk. Because, I mean, the difference between what Xenakis did and what you were just playing around here is that these are sinusoids, but Xenakis was drawing a composite, wasn't he?
He had a waveform, I think.
Yeah.
He drew the waveform.
So
then
he
drew
didn't
it.
know what sinusoids he was drawing.
No, and in fact, you could listen to these things as waveforms if you wanted to.
Right. But in terms of the actual connection with the sound,
Mm-hmm.
he was kind of just blindly drawing. But if you were to use one of those shapes to represent a packet of sinusoids and hear it and then morph it, that seems to be pretty powerful. Yeah, it just
Ought to be, yeah.
no, I mean, you can have an object that is more than 4 sides. It could be a polygon with
Oh yeah.
12 or 15.
Oh yeah, you can make arbitrarily complex shapes.
And then you could control parts of it to shape the harmonicity or impermeability, density of different parts of the spectrum.
Mm-hmm. Yeah, you could just hook it into your favorite synthesis parameters and go to town.
It would be a totally different way of representing. Instead of seeing it as striations, you'd be seeing it as something else.
Yeah. There is a problem of different parameters require different amounts of resolution. And screen position turns out to be good for things with about 1% resolution. But things that have like only 5 meaningful values, shouldn't occupy a whole lot of screen real estate, but then if you make it too small, you can't see it. And then things that need a lot of resolution, like pitch, can't really be done on a screen anyway. So that's a limitation that hits pretty fast. For the pitch thing, one thing is you just throw down a number that says, here's the base pitch, 60 please, and then 100 pixels is a halftone around that, say. And that works until you want to make a big gliss. So you end up just fiddling around trying to make the thing fit your needs. It's still very clunky. Oh, and another aspect of the clunkiness is the mess that you get into when you try to get back and forth between that and the sound, the business of making the sound. In fact, the better example was the thing I made. This stuff that you have to make in order to get the data out. This is kind of painful to program these things. There should have been some tighter glue between the graphical scores, the data stuff, and the objects, the sort of process-oriented object building aspect of it. But I have never been able to find a good design that really does that well. yeah,
It's 12.
it's 12. Oh, so it would be a,
And
and
playing sketch.
yeah, I've got to get back to the hotel at 2ish. So, but this might be a good moment to knock off because I think.
Well, if you have more questions, just come up and ask
Yeah.
afterwards.
Yeah, I'm not in a huge hurry.
I'm sorry, you are Elizabeth. Don't ask me though.
Yeah.
Very much.
Well, thanks.